This section, we're going to be talking about confounded experiments. So we're still talking about the two-group experiment, and these concepts about confounding are going to always be present when we're talking about any experimental design. So later when we start talking about larger experiments, we always want to keep these confounding issues in the back of our minds. So when we talk about a confounded experiment, we're talking about having an extraneous variable that is varying systematically with the independent variable. I think it's best illustrated with an example. So let me give you an example and then I'll try and define it a second way. Okay, so let's imagine that we're interested in the effects of bottle feeding versus breastfeeding. So our independent variable is, I guess, method of feeding. Bottle feeding versus breastfeeding on the development of diarrhea. Okay, I know this is not the most glamorous research that you've ever heard of, but so we're concerned about whether the style of feeding, either bottle feeding or breastfeeding, is associated with diarrhea in infants. So we want to see whether the group of infants who are bottle fed have diarrhea at a higher rate or a lower rate or the same as infants who are breastfed. Okay, so that sounds like a pretty simple question, and you could probably be thinking in your mind about lots of reasons why one or the other types of feeding methods might be associated more with diarrhea. One of the things that I wanted to point out, though, is like a systematic variable that might confound this experiment, where, in fact, this is an actual study where they actually randomly assigned moms to use bottle feeding or breastfeeding, and then they actually measured through mom reports how often the babies had diarrhea. So the thing that we want to keep in mind is that there could be some other variable that is systematically varying with the independent variable. So, for example, it could be that mom's level of education is impacting their adherence to the assignment of bottle feeding versus breastfeeding. One thing that research has shown is that moms who have higher levels of education here in the U.S. are more likely to breastfeed. And in other parts of the world, it's actually inversely related, where higher levels of education are associated with higher levels of bottle feeding. So we need to know where the research was conducted. Maybe we need to know within that society what the mother's level of education is, so that we know whether it's more or less likely that mom is adhering. Like if you are a mom with here in the U.S. with higher levels of education, and so you're aware of the values of breastfeeding and things, if you've been randomly assigned a bottle feed, it's possible that you might be bottle feeding your pumped breast milk and saying, well, I am bottle feeding. And it might be that, we're getting a confounded experiment where we aren't really testing breast milk versus formula. We're just testing style of introduction of the food by accident, right? The higher educated moms might not want to just bottle feed, as opposed to, like, if we were in another country, that more highly educated moms are more likely to bottle feed a lot of times because of work restrictions and things like that. And so they might not adhere if they were assigned to the breastfeeding category. And so we might have this confound that's systematically varying with the independent variable. And so when we see diarrhea rates, we can't be sure if those diarrhea rates are due to what the baby was feeding or, this confounding variable that's causing the mom to adhere to the protocol more or less. So the idea with this confound is kind of similar to the third variable problem in correlations. They are called different things. They work slightly different ways, but what we're talking about is very similar. Something other than what you're considering is what is actually causing the effect on the dependent variable. In this case, we're talking about, maybe the experimental group being different from the control group in some systematic way. Something systematic is happening. Now, in this case, I gave you an example of them acting differently because of some characteristic they brought with them. I'd like to throw in other examples, like, for example, if in your research design, you've decided you're going to run all your control participants in one period of time, maybe either in one sitting, or maybe this week is the control group time and I'm running them independently one by one, but it's all happening this week. And then another week I'm going to do the experimental, or in a whole, one big group setting, I'm going to run the experimental group separately. If something happens out in the world that impacts one group differently from the other, like let's say, for example, there's a snowstorm that makes it difficult for the participants in the control condition to get to the experimental lab setting, and that is not present for the experimental group. Everything's cleared up and everybody's moving normally again. If something like that happens, that weather could serve as a confound where the control group experienced something different that might have had an impact on their performance on the dependent variable that the experimental group didn't experience. Or it could happen vice versa, right? Where the experimental group is having, maybe they had a power outage during their group administration of the experiment that didn't happen to the control group. Something like that. Things can happen that are completely random that can serve as confounds, as extraneous variables that are systematically varying with the independent variable. So one of the things that we do to get around weather and things like that is you don't really want to ever say, okay, this week is my control group, right? You want to sort of alternate control group member, experimental group member, control group member, experimental group member, so that it's more likely that those kinds of extraneous variables will be distributed across both groups. Right? Then you have a little bit more control if you spread it out across both groups. And the best way to spread it out around across both groups is to not do experimental bulk control. I had a grad student a couple of years ago who did a study where we tried to make everything as the same as we could. She needed intact classrooms of students to take the test. So I was teaching Psych 309 at 11 a.m. daily. My colleague was teaching Psych 309 at 10 a.m. daily. So we're like, well, it's the same class. It's almost the same time of day. You could come on one day, test that class, test this class, and then you'd have two basically the same classes. One thing we forgot to take into consideration is that I had a full class at 45 students, and my colleague had, 21 students, I think, in that class. So there's one big difference right there. Of course, the teacher's different in the two groups. So it's possible that somehow we were influencing the students differently. We started thinking about all the possible extraneous variables, like how much would this impact performance on the dependent variable. One of the problems with having intact groups like that is that you do run the risk that, something really different might have happened in the 10 a.m. session versus the 11 a.m. session, right? And that it has nothing to do with the independent variable. It only has to do with some extraneous thing. So my grad student was very aware of noting anything that was different between the two classes, anything, right, besides sample size. Anything that was different between the two groups. We randomly decided which of the two classes would be the experimental condition and which would be the control condition, used a flip of the coin, things like that, just to try and make everything as similar as possible, given that we had to test them in intact classrooms to test the hypothesis. But it's a risk because just one little thing being different, like a light bulb blown out in the 10 a.m. class versus the 11 a.m. class, could have been the difference in, an extraneous variable or everything being smooth. So I want you to be thinking about always when you see results, whether it's a correlation or it's a two-group study, whichever way we're talking about, always be thinking, okay, what else outside of what was being controlled could account for this behavior, for this outcome on the dependent variable? I'm going to give you an example. So on this video, you're going to see a horse that they claim can extract square roots and cube roots, which I think is pretty impressive, because especially the cube root is pretty difficult for most of us, right? So if this horse can do it, that's pretty impressive. So I want you to watch the Wonder Horse and think of any other alternative explanation for how this horse is doing it, other than the horse can do square roots and cube roots. Like, think about what might be going on in the experimental setting that could allow the horse to figure out what the correct answer is, separate from the horse having this amazing ability. Okay, so watch the video, and then we will come back and we will talk about what you saw and possible interpretations.